Continuing in Chapter 7, this is again the same example, but we're going to run it with the calculator this time. And so, same bell curve. I'm going to round again just to keep the visual simple. Centered at about 39. Counting by about 3. So, 3, up 3, up 3. Down 3, down 3, down 3. We're looking for a target range of less than 35 inches tall. So 35 is about there. Less than is this side. So again, in the calculator, we have the left and the right bound. And so depending on how you shade will determine what you put in the calculator first. This is the left or the lower. This is the right or the upper. And remember, this continues to negative infinity. So it's negative 10 to the 99th power. So we have to put in negative 10 to the 99th first. Anytime you have a left tail, left test, you're going to put in the negative infinity first. So anytime you're doing less than a number, negative infinity goes first. Then your upper bound, which in this example is 35. Your mean has to be exact, 38.72, and the standard deviation of 3.17. So you can round in your picture, but don't round in your calculator. We're going to enter this in. Second vars, normal CDF. Make sure to use the negative sign, not the subtraction sign. So it's negative 10 to the 99th power, upper bound of 35. 38.72, 3.17. In that order, we go to paste. With the older calculator, you just type it in, negative 10 to the 99th power. 35 is our upper, 38.72 is our mean, 3.17 is our standard deviation, and we will run it. And we get about the same answer, 0.120. So it's off a little bit in the homework knows that. The My Math Lab knows it's going to be off a little bit if you use the chart versus the calculator. So either way, you get those answers. Now, example 1 follow-up at the very bottom of page 6 says, what is the probability that a randomly selected 3-year-old female is between 35 and 40 inches tall? So I'm going to use the same visual from up top, just use a different color here, between 35 and 40. 40's somewhere in here. So the 35 becomes the left bound, and the 40 becomes the right bound. So we'll do a normal CDF. For the betweens, normal CDF is really nice. With the chart, you have to do 2 separate calculations. With normal CDF, you can do it all at the same time. So lower bound is 35, upper bound is 40, mean is 38.72, standard deviation is 3.17. So for the between questions, I strongly recommend the calculator. So normal CDF, 35 to 40. This one doesn't have any infinities. Mean and standard deviation. And you should get 0.5365. So that's that middle portion of the data. So pretty big probability because we're talking about the main part of the curve. So normal CDF in the calculator we're going to use over and over and over again. We're going to use it again in Chapter 8. So definitely learn the calculator. If you prefer the chart, that's fine. You can use the chart, but at least learn the calculator because we will be using it a lot in Chapter 8. Alright, so that is given a target range, finding the probability or the area. Now we're going to work backwards, given the area, to work back to find that target value. Alright, so when you are given a probability, which is a percentage, or you're given the area, so they sometimes they call it a probability, sometimes they call it an area, same idea, and you want to find the target value, which is your x value, we can use, again, the chart or the calculator. In this case, the calculator is much easier. The chart is rather tedious for this process. All right, so for the chart, we have to determine if we need to subtract the probability from 1. And so it might also say area. Probability or area from 1. We have to think about, is it a greater than or a less than area? So if it's an upper or a greater than, we have to subtract from 1. We look up the probability in the chart as close as we can, which is kind of the tedious part. Determine the corresponding z-score, and then they use the z-score formula to find the x value. Now the nice thing about your formula chart, where'd it go? Back on page 2, the nice thing about the formula chart is it's done the algebra for you here. It tells you how to get x if you have mu, z, and sigma. So it's kind of nice. All it's done is rearrange this for you so you don't have to do the algebra. You can just plug in your values. So that is there for you. I'm going to write that down here. X equals mu plus z times sigma. So that's one way to do it, kind of the long way. The quicker way is to use the calculator. Again, you still have to determine if we need to subtract from 1. The function in the calculator is programmed to the left, so we have to think about that. Then we use a new function called inverse normal, and I apologize, that should not have cut to the next line. Sometimes my formatting gets off. All right, so there's 3 arguments for inverse normal. And it's kind of confusing because normal CDF has 4 arguments, inverse normal has 3. The first argument is the area to the left as a decimal, and then the mean and the standard deviation. So it just has that one area, it just assumes to the left the mean and the standard deviation. If you enter 0 for the mean and 1 for the standard deviation, it will give you the z-score. So sometimes the homework just wants the z-score, so you put in 0 for the mean and 1 for the standard deviation. Okay, so let's practice this. I'm going to show you one time by hand and then in the calculator, and we'll use the calculator for example 4 as well. Alright, so still talking about those 3-year-old females. Remember they had a mean of 38.72 and a standard deviation of 3.17. So it says find the height of 3-year-old female at the 20th percentile. So think about percentiles. Remember percentiles back from chapter 3. That is 20% of the data is to the left of the 20th percentile. So we do not need to subtract from 1. The area that we're looking at is 0.2, so converting the percentile to a decimal. So what we're going to do, and it's exactly 0.2, this is again kind of tedious. If you do this by hand, you go into your chart on page 6. I wish I could zoom the camera in, but I can't. I'm just going to pick up the paper and see if you can see. What we need to do is look at all the values in the chart and get as close as we can to this 0.2000. So if you look at your chart, the smaller numbers are up top and the bigger numbers are at the bottom because it always goes to the left. And in your chart, you should be able to find 0.2005. That's the closest we can get to 0.2000. So that's a little tedious, like I said. Then you go out and up. So out and up. So you get a corresponding z-score of negative 0.84. Negative 0.84. So that is our z. We know our mu and our sigma from earlier. So we can use the already solved formula, which is kind of nice. X equals mu, which is the 38.72, plus the z we just figured out, negative 0.84, times the sigma, 3.17. So it's done the algebra for you, and all you have to do is plug that into the calculator, let it crunch the numbers for you. 38.72 plus negative 0.84 times 3.17. So just be careful with your typing. The negative button is here, not subtraction, so be aware subtraction and negative are two different buttons on these calculators. It will do all that work for you, and it gives us a target value of 36.0. I'm going to round that to 6. So they're saying that height is at the 20th percentile, and it should be less than your mean because we're on the left-hand side of the mean. Doing the same thing in the calculator. Again, you still have to think about if you have to subtract from 1. Because it's the same scenario, we do not subtract from 1. And that's because, again, percentile is already to the left, so we're okay. We're going to use the function inverse normal, which is under second vars. It's right below normal CDF. Inverse normal. The newer calculators kind of spoil you, asking for the area, the mean, and the standard deviation. The older calculators, if you go to inverse normal, you have to remember what to put in. It's the area, 0.2, the mean, and the standard deviation. The calculator will look up the z-score and work it out and solve it for you. So 0.2, 38.72, and 3.17. And it will automatically give you that target value, 36.05. Again, it's always a little bit different than the by hand method, which is fine. The homework knows that there's a slight difference. So that gives you an x value of 36.05. If you need the z-score, which I know there's some homework problems where you do, you put in 0.2, 0, 1. So inverse normal, 0.2, 0, 1. And it gives you that negative 0.84 z-score. So if you need the z-score, you just put in 0 and 1, and that is the z-score. Again, I'm not going to ask you for that on a test, but there are some homework problems that want that. All right, let's look at example 4, working backwards with an application problem. It says the scores earned on the mathematics portion of the SAT are approximately normally distributed with a mean of 516 and a standard deviation of 116. What scores separate the middle 90% from the bottom and top 5%? Now, we really have to think about what we're trying to do here. I like to draw this picture to just get a good visual of what we're doing. We know 5/16's in the middle. We're going to go 3 up and 3 down from that 5/16. So if we add the 116, add 116, and add 116 again, subtract 116, subtract 116, and subtract 116 again. So just again, nice visual. We are looking for the top 5% score somewhere in here. I'm not exactly sure where. This is the top 5% to the right of that value. I'm going to call that x2. And the bottom 5%, again, somewhere in here. This represents the bottom 5%. I'm going to call that x1. Now to solve for x1, the bottom 5%, we can just do inverse normal And we can use that 5% because the calculator is programmed to the left. So we can do 0.05 and then 5/16 and 1/16. For x2, you have to be a little bit more careful. The top 5% correspond with the bottom here, so 90% in the middle and that bottom tail. So all together, this represents 95% of the data. So because we're talking about the top 5%, I have to do inverse normal of 0.95 because it has to be to the left. This is an example of when I have to subtract from 1 because I'm looking at the greater than side of the curve. So I have to put in 0.95, 5/16, and 1/16. Alright, so let's crunch those numbers. We have inverse normal, 0.05, 5/16, and 1/16. That gives us a lower score of 325.2. And then inverse normal of 0.95. I just hit second enter, change the 0.05 to 0.95, and run it, and that gives us a top score of 706.8. So your bottom score, 325, should be somewhere in here, lower than the middle, and your top score should be somewhere up here, higher than the middle. So make sure the numbers you're getting fit the scenario using that bell curve. Alright, I think we're just about done with 7.2. There's some weird notation in your textbook. This is just in this textbook. I haven't seen it in any other textbook. But there's this notation called Z of the alpha, Z sub alpha. So the area is alpha, and it is the z-score such that the area under the curve to the right, sorry, it's a little small. So it's the z-score so that the area to the right of that z-score is alpha. Alpha represents area. So we're going to use alpha for different things, but alpha always means area. It's usually area in the tail. In the tail. By tail, I mean to the side, away from the middle. So to find the value of z sub alpha 10, this means the z-score with an area of 0.10 to the right. So we always put in the calculator or look up the other side of it. So because alpha is always in the tail, and we're talking about the top tail to the right, we always have to put in the other value to the left. So always 1 minus alpha every time. Because alpha is always to the right, our calculator always goes to the left. So we have to put in 0.90 for this one to be 1 minus 0.10, comma 0, comma 1. And that's going to give us the z-score that we need. So again, with this notation, which you'll see a couple in your homework, and always that 0.10 is always to the right, you always have to do 1 minus that number before you put it in the calculator. So inverse norm, 0.9, 0, and 1. And that is the z-score they want. They always want the positive z-score. In this case, it'd be 1.28 to the right of that alpha. So always 1 minus alpha here. Just wanted to show you that notation. This is always 1 minus alpha. Alright, that finishes up 7.2. Again, there's an extra example here. If you'd like to work that on your own, I can email you the answers, but you have plenty to practice in your homework as well. Alright, I'm going to stop there and I'll make a last short video for 7.3.